Dear students, I am Santhan, working as a physics faculty in Target English Medium School. Today, I would like to teach what is the Newton's third law of motion, and we discussed some activities to understand Newton's third law of motion from the chapter of laws of motion. Let me come to our topic directly. So, what is our concept? Newton's third law of motion. So, we know that it is very famous. To every action, there is an equal and opposite reaction. So listen very carefully. To every action there is an equal and opposite reaction. This is the third law. So already we discussed what is the first law and what is the second law. In case of first law and second law and third law, we are observing some comparisons. The first law and second law, in the two cases, mostly we can say a single object. But in the third law will be valid in case of two bodies only, but not in a single body, because of action and reaction pair is always acting on two different bodies. Is nothing but on the pair of the bodies only. On a single body, there is no action and there is no reaction. I will give you a suitable example for this one. Listen very carefully. So, Newton first law and second law we consider only on a single body. But the Newton third law of motion, according to that one, action-reaction pair is always acting on the simultaneously on two different bodies, but not in a single body. So that's why, according to the Newton's third law of motion, how many bodies we can say? Two bodies. One body will be exert the action, another body will be the reaction force will be exert. So to every action there is an equal and opposite reaction. Is nothing but what is that one? Action and reaction. Action and reaction are having same magnitude but in opposite direction. Listen very carefully. Action and reaction are having same magnitude but in opposite direction. Magnitude is nothing but value, numerical value. So means what is the action force is acting on the body, the same reaction force is acting on the body, but in which direction? Opposite direction. Is nothing but action is equals to reaction. So this is simply we can write f of AB or f of 1 is equals to f of BA. So here minus is represented opposite, means the force exerted by the A body on the B body, that is the action. Means always says that according to the Newton third law of motion, how many bodies you can say that action and reaction both are not acting on a single body. These two are acting on the different bodies. That's why. So A is the one body, B is the another body. That's why when the two bodies are for example, I will say that here. In this one, a block is placed on the horizontal surface of the table. Here, how many we are consider that in this one? Two bodies are a block is placed on the horizontal surface of the ground. We can say that horizontal surface of the ground. Now, on this body, we know that gravitational force is acting in which direction? Downward direction. Is it correct or not? So means, so on this body, okay, earth gravitational force is acting vertically downward. At the same way, the surface of the body is applied some force on the body in vertically upward, that is called normal reaction or normal force. Okay, once again listen very carefully here. A block is placed on the horizontal surface of the ground or floor. Here you are observing the two bodies. One is the object, another one is the floor. We can say that floor is nothing but earth. Now this object is placed on the floor, then what will happen? This floor, this object is pulled by the gravity in downward. So it's nothing but this duster. So all I say is that the duster is just like we can say as an object, it is placed on my palm. So this duster we can say as a brick, its mass is 1 kg. On 1 kg mass of the brick, how much force is acting downward? 9.8 Newton is nearly equals to 10 Newton. 10 Newton force is acting downward, that is the actional force. But so if the actional force is acting on this one, it is not going to down. But why means so on this one, my palm is acting some force on this one vertically upward, that is the normal force or normal reaction. For which one? Gravitational force. That's why here, how many bodies are there? Two. One is this body due to the earth gravity. Listen very carefully. On this body, earth gravitational force is acting downward. That's why when one body is placed on another body, this body will exert some force on my palm, through the which one? Gravitational force. Sorry, by the gravitational force. Then that's why the brick, it is acting some force on our palm by the gravitational force, that is called action. It is the action. At the same one, our palm is exert some force on the object in vertically upward, that is the reaction. So that's why normal force is the reaction. So now here we are observing that, so this duster is apply the force on our palm, that is the action. Our palm will apply some force on this one, that is the reaction. But only this duster only I can say that on the duster, which is the action, which is the reaction, only one. Means you don't consider the palm. The duster we can keep on the palm, but don't consider the palm. Only we can consider the duster. On the duster, or you tell which is the action and which is the reaction. Is it possible? No, because of in a single body, so we cannot explain action and reaction. So action and reaction forces are simultaneously, but these two are acting on the different bodies, but not in a single body. That is one. So that's why it says that. So what is the Newton's third law of motion? To every action there is an equal and opposite reaction is there. Action and reaction having same magnitude, but in which direction? Opposite direction. Action is equals to reaction. F of AB is equals to minus F of BA. Means A body is applied some force on the B body. Like the duster or brick is applied some force on the palm. Like the same way, the palm is applied some force on the duster in which direction? Opposite. The brick is applied downward, but our palm will be applied upward. That's why both are equal in which value? Equal in the value, but in which direction? Opposite direction. How we can say both are equal in value when the brick will be placed on your palm 1 kg. So this brick is going through our hand and fall onto the earth? No, because of the brick is in which position? Still it is in the equilibrium or rest position, because of on the brick two forces will be acting. One is the gravitational, another one is the normal reaction. But these two are having equal value but in opposite direction. That's why the resultant or net force is acting on this brick is 0. Like the same way we discussed, when you can throw a ball towards the wall, if the ball touches to the wall, immediately the ball will be rebounds back. Is it correct or not? Into the same path. That is also one of the best example for which one? Newton's third law of motion. For every action there is equal and opposite reaction. Now we discussed two activities. to prove action and reaction both are action reaction have same magnitude but opposite in direction. But in opposite direction. So now we are observing that to prove action reaction have same magnitude but in opposite direction. Is it correct or not? Discuss. First of all, you can take a large horizontal surface of the table, and now we can take two spring balances having are graduated same markings on their outer surface. So listen, first of all we can if you can conduct to this experiment to proving action reaction have same magnitude but in opposite direction, means what are the materials are required to us, means a table, weight hanger, string, two spring balances and one fixed position, means heavy weight. Now we can take the two identical spring balances. The two identical spring balances of one end we can attach with each other. This is one end, this is another one. These two are attached with each other, and so one spring balance we consider as A, another one we can consider as a B. So the B spring balance of the other free end is connected to the a fixed rigid body through a string. Now another free end of the A spring balance is connected to a weight hanger by passing through over a pulley. Listen very carefully. We can take the two spring balances. The one end of the spring balances are tied together, and another end of the B spring balance is connected to a fixed support through a string, and free end of the A spring balance is connected to a weight hanger by a string, by connected to a weight hanger, connected to the weight hanger by passing over a pulley. Listen very carefully. Another free end of the spring balance is nothing but a free end of A spring balance is connected to the weight hanger by a string, through a string by passing over a pulley. This is the one is there. Now initially in the weight hanger no weights are added or no weights you can keep here. At that time we are observing that what is the readings on the A and B spring balance. So initially the reading on the A spring balance and B spring balance, just consider that a reading on A spring balance, reading on B spring balance. So reading on the A balance spring balance, reading on the B spring balance, we have considered that. So initially what is the reading? 0, 0, it is the Newton. So means why? Because of no weights we can keep, no weights we keep into the which one? Weight hanger. At that time the A spring balance and B spring balance both are, we are observing that both are showing 0 Newton. We can say that. Now slowly we can add it. First of all, we can add the 50 grams mass of the 50 grams weight in the weight hanger. When you can add the 50 grams, at that time you are observing that. So it means when you can add the 50 grams here, what will be happen? This weight hanger, is connected to the which one? Spring balance by a string. Is it correct or not? That's why when you can add the weight in the weight hanger, on the weight hanger, which force is acting? Gravitational force is pull the downward. That's why this weight hanger, due to the gravitational force pull to the downward, that force is acting on which one? On this spring. That's why on this spring A, means spring balance A, some force is acting by this weight hanger. That's why the spring balance will be trying to tendency into the move this direction. But when it is trying to move into this one, this spring balance is coming along with this one? No. Why? Because the spring balance is already fixed, connected to a fixed position. That's why it is in the rest only. Then if it is move certain move distance, that's why the reading will be showing, for example, 5 Newton. At that time, you are observing what is the reading showing in the B spring balance also, 5 Newton. Next, you can add the 100 grams. At that time, 10. 150 grams, 15. So that's why if you can repeat that experiment, so up to the elastic limit, you are observing that. What you are observing that? So if A spring balance will be showing the 5 Newton reading, B is also showing the 5 Newton. It is the 10, it is also 10. It is the 15, it is also 15. That's why. So on the A spring balance, by the gravitational force acting on the weight hanger, on the spring balance A, force is acting. That is the action. If this spring balance is trying to pull this direction, but this spring balance is connected to one fixed support. That's why this one is not set into the motion. It is offered some opposite force by this one. That is the reaction. Is nothing but simply we are observing that if you can take two spring balances A and B, the two ends of the spring balance is connected together and another three ends are held in your hand and try to apply the force. Means like this, it is a hold fixed position, this one. With help of this one you can try to pull. Then what will happen? So you are applying the force on the A balance but not B directly. But A and B are connected together. That's why when you are applying the force on the A, that is the action. Means A spring balance is applied some force on the B, that is the action force. But at the same time, B is also applied some force on the A, that is the reactional force. So in this one, A spring balance is applied some force on the B, that is the action, and B is also some force on the A balance, that is the reaction. Okay, so that is one. If here this B spring balance is not connected to the fixed support, then what will be happen? It is also set into the motion. But here it is connected to the fixed one. That's why it is always in the constant. At that time, with help of this fixed one, the spring balance B is applied or offer some opposite force on the A. That's why you can write that F of AB means force applied by the A spring balance on the B, that is equals to, okay, F of BA. Force applied by the B spring balance on the A, but in which direction? Opposite. It is the action, it is the reaction. That's why you are observing that in this one. So A will be 5, B is also 5. It is 10, it is 10. It is 15, it is 15. That's why what is the reading showing in the spring balance A, the same reading will be showing in the B. That's why what you have considered that. So the magnitude is the same, but in which direction? It is pulled to this one, it is pulled to that one. That's why in opposite direction. So what we can write here means, so first of all we can take the two identical spring balances. One end of the spring balances are connected together, and one is we can say as a A, another one we can consider as a B. Free end of the A spring balance is connected to the weight hanger by passing over a pulley through a string. Free end of the B spring balance is connected to a rigid or fixed support on the table. Now, in the weight hanger, if you can add 50 grams weight and observing what is the reading shown on the A and B. Like next, we can add the weight up to the elastic limit, or okay, up to 3 or 4 times 100 and 150. For each and every case, you are noted the corresponding readings on the A and B. Then finally, you are understand that what is the reading showing in the A. For each case, the same reading will be shown on the B. That's why. So means A will be applied how much force on the B. B is also applied the same force on the A, but in opposite direction. That's why. So action and reaction space are always having equal magnitude, but in which direction? Opposite direction. It is very, very important for 4 marks. And for the 4 marks, you can draw this diagram also. Activity 2. It is a lab activity. Activity 2. Under the activity 2, we discuss a lab activity. For which one? Action, reaction, pair. Action and reaction is a pair or not. For that one, we discussed one lab activity. So what are the materials are required to conduct this lab activity to prove about action and reaction is a pair? A retarded tank, this one laboratory retarded tank, an empty test tube, a rubber card, this is the rubber card, water, strings, these are the strings, and it is the Bunsen burner. So in this one, so here, first of all, we can take an empty test tube made up of borosilicate. Now the test tube is filled with water up to little bit. Means first of all we can take an empty test tube. The test tube is filled with 5 ml of water. Now the open end of the test tube or mouth of the test tube is closed with this rubber card. This is the rubber card. Now this test tube you freely suspended in horizontal mode with help of the strings, with help of a rigid support through the inextensible string. First of all, we can take the empty test tube. Listen very carefully. First, we can take an empty test tube. The test tube is filled with water up to little bit quantity. Now the open mouth of the test tube is closed with a rubber card. After that, now the test tube is freely suspended in the air horizontally with help of a rigid support through the inextensible string. Now we can slowly heat the water in the beaker with help of the now we can slowly heat the water in a test tube with help of the Bunsen burner. When you can gently heat it at the low flame, you are observed up to the water will becomes to boil or vaporized. So when the water will be vaporized, then what will happen? You know that the water in the test tube is absorb the heat energy. When the temperature of the water is reaches to the 100 degrees Celsius, the water is converted into the water vapor. It is nothing but vaporizing. So the water in the test tube is we can heat it up to the vaporized. When the vaporized water, what will happen? The water vapor density is less. That's why it will be try to come outside and goes to the higher altitude. Due to that one, this water vapor will become and touch to the which one? Rubber card. But this water vapor is comes to outside. Here, what is that one? Rubber cork is acts as an obstacle because of the pressure inside the test tube is more than the pressure outside. Due to that one, the hydrostatic pressure of the water vapor from here to here, it will be try to come. Due to that, so it is the higher vapor pressure, here lower vapor pressure. That's why this higher vapor pressure will be try to come to the lower vapor pressure. What is here is there? Rubber card is acts as an obstacle. That's why if you can continuously heat it up to one certain particular time, you are observing that the vaporized what is increases here, then it will be apply a huge force on the rubber card, then rubber card will be spell out like this one. The rubber card will be spelled out. This is the action. When the rubber card will become outside from the test tube will be moved to the backward. So here rubber card means on the rubber card water vapor is applied some force, that is the action or nothing but that is it. If the water vapor is applied some force on the rubber card, then the rubber card will become outside or spell outside. That rubber card will become outside from the mouth of the test tube, that is the action. When the rubber card will become outside, then you are observing the direction of the test tube, it is comes to backward, that is the reaction. So rubber card will become outside, that is the action. Test tube is moving to backward, that is the reaction. That's right. So in this concept, we are observing action and reaction is a pair. Means both are will be happen simultaneously at a time. The rubber card will come outside, immediately it is going to back. So this is the one of the activity to prove or understand action and reaction is a pair. So first of all, we can take an empty test tube filled with water up to a little bit quantity. and the open end mouth of the test tube is closed with a rubber guard. Now the test tube is freely suspended in the air horizontally with help of a rigid support through the inextensible string. Now the water is gently heated in the test tube with help of the Bunsen burner until the water is vaporized. If the water is vaporized, the vaporized water is apply some force on the cork, then the cork will become outside. That is the action, and immediately the test tube will become moved backward. That is the reaction. That's why what you are understanding that action and reaction is always acting on the different bodies but not on a single body, and action and reaction is always it is a pair only.